Hey geometry class, I've made this review for you today because I realized that I wasn't going to be able to be there today. My daughter isn't feeling well, so pray for her if you want to, and I'd be proud of that. Anyway, I wanted to make sure y'all had a good review before the test day. I didn't want to leave y'all high and dry, so let's go ahead and get started on what's going to be on this test. Alright, so first thing that I'm going to go over is a proof. And if you need me to do any more proofs than this that you found in the homework, not on the proofs part of the test, the part 1 of the test that I gave you, but this is actually one of them that I did for the freshmen in the class. So freshmen, if you didn't do this, copy this down, and sophomores, I suggest you do the same thing. So this is the one that I did in class yesterday, and you know, you guys have the statements, and I've asked you to list the reasons for each of the statements that you're given. So this is how it's going to be on the test. The actual test for tomorrow also is very similar how the part 1 of the take-home test is. So let's just get started on this. What in a proof you are given is, well, you are given some information, and then what you're trying to do is get to this point right here. Your last statement is going to be that BC equals CD. That's the case for every proof also. You start with the given, you end with what you're trying to prove, this statement. Anyway, so what we're going to do, like I said, let's start with the given. The AC equals CE, and AB equals DE. So that is given, so write given. Step 2, this is what it lists for step 2. And as I stated in class the other day, this statement actually has 2 statements within it, and they both are the same basic type of thing that it's using. Let me write this down and try to talk here in just a second. CD plus DE equals CE. Okay, we need this statement. We can't necessarily show that step 2 comes from step 1 like we've done with algebraic proofs in the past. What step 2 is the segment addition postulate, and that is often or almost always used whenever we are proving segments congruent or segments equal to each other. And in this case, we are proving segments are equal to each other. So we are going to use what we know with the segment addition postulate to help us in figuring out our statement, the proven part of our statement, okay? So on step 2, list this right here. This statement is the segment addition postulate, which is going to help us in proving the next few statements. Okay, I'm just abbreviating it there. All right, the next statement is this here. We have AB plus BC equals CD plus DE. Well, the reason we know this statement right here is true is because look at the previous statement and look at statement number 1 also. We have AB here plus BC, that's that, equals CD plus, that's supposed to be DE. DE. There, fixed it. All right, and then that's this right here. So AB plus BC equals CD plus DE. And that is true because look what it equals. AB plus BC equals AC, which is right here. And then CD plus DE equals CE, which is right here. What's happening is they're taking this right here and substituting it in for AC. Same goes for this statement right here. They're taking that and substituting it in for CE. So this step right here is substitution, the substitution property. And like I said before, I don't care if you write substitution property of equality or property of congruence or something like that. Just, they all are one and the same, so just write substitution property just to keep it short and simple. Okay, statement 4 is this right here, that DE plus BC is equal to CD plus DE. Well, what changed from 3 to 4 is this right here, that they replaced or substituted, notice my words, DE in for AB. That's the only thing that changed between 3 and 4. And they were able to substitute it because of this statement right here, AB equals DE. All right, so we substituted in, and the reason they substituted that in is because the next statement, let's write this for substitution again. Okay, the reason they wanted to substitute DE in for AB is because we can conclude from this that BC does equal CD, because right here, I'm going to write it really small, we can subtract DE from both sides of our equation and end up with BC equals CD. So to go from 4 to 5, we use the subtraction property. And that is it on this proof right here. And that's the way you're going to have to follow the rest of the proofs in this section, or in this on this test. Okay, whenever you come to problems that have angles in it and you are adding angles together or subtracting angles together to get down to the two angles that you're trying to prove congruent or equal to each other, you're going to be just like using the segment addition postulate, showing that segments are equal to each other for angles that are in the figure that you're given, that are being shown congruent or equal to each other, that are being added together. You're going to be using the angle addition postulate. So that's what 2 of your proofs revolve around, is the segment addition postulate and the angle addition postulate. The other proof on the test is going to revolve around vertical angles and the transitive property, and showing that those angles are congruent to each other. So look over and study your part 1 of the test to help you on part 2 of the test, on the 3 proofs that you have on it. Like I said, you're going to have to give me the reasons. And speaking of the reasons, you will be able to use that half sheet of paper that I gave you yesterday If you don't have that, I'll have the sub handed out to you in class today. All right, so what is going to be on another part of the test is something like problems 22 through 27 on page 120 of section 2.7. And the description of this is in the directions. What you have to do is determine the statements that you're given on problems 22 through 27, if they're true or false according to this description that's given. So what I would suggest very strongly is from your description, create a drawing. And then from that drawing, it will help you answer your questions, whether they're true or false. So on this one it says two lines that are not perpendicular intersect, such that angle 1 and angle 2 are a linear pair, and angle 1 and angle 4 are a linear pair. Angle 1 and angle 3 are vertical angles. So linear pair means that these two angles are supplementary. And remember, these are lines that are not perpendicular, but they intersect each other. So what it's going to look like, something like this. They intersect, but they're not perpendicular. And then it says 1 and 2 are a linear pair. All right, so on one of the linear pairs, like this side of the one of the lines, because right here, if you ignore this half of the drawing, angle 1 and 2 are on the same line, which is a straight angle, and that is they are supplementary, meaning they're linear pair, supplementary, they go along with one another. If they're a linear pair, they are supplementary. But anyway, here you have angle 1 and 2 are a linear pair. Now, angle 1 and 4 are a linear pair also. So you already have angle 1. Put angle 4 down here because, again, that's a linear pair to angle 1. It wouldn't make sense to put it over here because angle 1 and 4, that would make them vertical angles rather than a linear pair. All right, the last thing, it says angle 1 and 3 are vertical angles. Well, angle 1, go across, that's angle 3. So there you have a drawing of what your description is stating there. Now, go through all the true-false questions and tell me whether they are true or false. And you will have statements such as angle 1 is congruent to angle 3. Well, that is true because vertical angles are congruent. And angle 1 and angle 3 are congruent, so that would be true. You may have another statement like, well, angle 1 is congruent to angle 2. Well, they would not be congruent here in this case because they are a linear pair, and the only way linear pairs are congruent to each other is if they intersect at a right angle, and meaning both of them, angle 1 and 2, are 90 degrees. But that's not this case because up here it says not perpendicular. So this is false. Okay, you may have another statement that deals with supplementary angles. Remember, linear pair, they're supplementary. So you can have something like that says angle 1 plus, well, measurement of angle 1 plus the measurement of angle 2 equals 180 degrees. Well, linear pair means that these angles are supplementary, so this right here is true, that these two angles add up to 180. Another statement you may have something like measurement of angle 1 plus, say, the measurement of angle 3 is equal to 180. Well, we can for sure say that this is false because these two angles are vertical angles. Vertical angles will never add up to 180 degrees. So say false. Okay, so you'll have questions like that. So here's another problem that is going to be similar to what you have on the test. You're going to be asked to find all other angles if you're given. Angle 4 is a right angle and angle 5 is 35 degrees. So this is the way I want you to start out. Just start out with the angles that we know. Measurement of angle 5 equals, that's supposed to be in the instructions, is 35 degrees. And we also know the measurement of angle 4 is equal to 90 degrees because it is a right angle. Okay? Now, let's find the rest of them. If we look at angle 5 and angle 1, we can see that they lie on the same line, meaning they are a linear pair. And linear pairs are supplementary. That means they add up to 180. So we can find the measurement of angle 1 by saying 180 degrees minus our angle 5, which is 35. And subtracting those, we get 145 degrees. And there we got a measurement of angle 1. Okay, so now let's look at the measurement of angle 2. Okay, the measurement of angle 2, if we look at this picture here and ignore this line right here coming down, we could see that these two lines right here intersect, meaning angle 5 and angle 2 are opposite of each other, and those are vertical angles. And remember, vertical angles are congruent, which means angle 2 is going to have the same measurement as angle 5. So that's 35 degrees. Now to find the last one, angle 3. And since angle 4 over here is at a 90-degree angle, that means over here, this angle is going to be 90 degrees. Meaning 2 and 3, those two angles are complementary. They add up to 90. So we can find measurement angle 3 by taking 90 and subtracting our angle 2 from it, which is 35. And we end up getting 55 degrees. And there we have it. We found all our angles in our figure here. And that's what you're going to do on the test. Okay, another figure that you could be given on the test is something similar to this. You will be given some angles that are congruent to each other, and then you'll be given one other angle and asked to find what is one of the other angles that you need to find. Okay, so what this is stating up here is angle 1 and 2 are congruent, 2 and 3 are congruent, 3 and 4 are congruent. So all in all, we can say 1 is congruent to 3 by the transitive property. And if that's true, 1 is congruent to 4 also. Same goes with 2. 2 is congruent to 4, and with all that with the transitive property. So we know angle 1, angle 2, angle 3, and angle 4. All of those angles are congruent to each other. And how I'm going to tell you to do this is, okay, we don't know angle 1. Let's put an X on it. 2 is going to get the same thing because it's a congruent angle. Angle 3 and angle 4. Let's call these all X. That's what we're trying to figure out. What is X? Because the measurement of angle 2 is equal to X now. And then angle 5 here we have is 20 degrees. Because that's given right here. Well, if we take all of these angles and add them up, and this is along a straight angle right here. All of these angles are going to add up to 180. So what we need to do is take x plus x plus x plus x plus 20, all of our angles, add them up, set it equal to 180. So this is 4x plus 20 equals 180. Solve this equation. So we have 4x, and now subtract 20 from both sides, we get 160. Now divide both sides by that 4, we get x is equal to 40. So what this means is all of these x values that I just told you up here are equal to 40 degrees, which means the angle that I've asked you to find, measurement of angle 2, is also 40 degrees. So measurement of angle 2 equals 40 degrees. And that's how you're going to find your solution. Okay, let's move on. Alright, so just like you did in your homework in section 2.7, you're going to have a problem similar to those, where you're asked to find the measure of each angle, and you're given something, a figure like this. So here's what we're going to do. We're going to find x and y first, and then we're going to plunge back in to figure out what the measurement of each of our angles are. And how we're going to find x and y is knowing that vertical angles are congruent. And so these two angles right here across from each other are congruent, and these two angles are congruent. And we're going to set up an equation to show that we know that they're congruent, meaning they're equal to each other also. So 2 times 5x minus 5 equals the 6x plus 50. And then for the y value, do something similar to that. To find y, you say 5y plus 5 equals 7y minus 9. Solve each of these equations for your variable. So here we get 10x minus 10 equals 6x plus 50. And then do your solving of equations. So I'm going to subtract 6x. And then in another step, I'm going to do this. I'm going to add 10 to both sides. So that gives me 4x on this side and 60x on this, or 60 on this side. And then divide both sides by 4, we get 15. Okay. Before we go and figure out our angles, let's figure out. Shoot, I'm getting tongue-tied, people. Anyway, let's find y. So again, let's do subtracting things from both sides like that, and then adding to both sides to get, let's see, 14 equals 2y. So divide both sides by that 2 to get y by itself. We get y equals 7. So whenever we get x and then y, what we're going to do is take our numbers that were given and plug them in for our x values and our y values in our equation. And what you're going to end up getting is this right here. I'm going to say 2 times 15 minus 5. That ends up equaling 140 degrees. Well, we know that these two angles are equal to each other, so we have two angles that measure 140 degrees. And then plug in for y, our number 7. This is what we're going to get. We get 5 times 7 plus 5. Well, that's 40. And so our other two angles have y in it, are both 40 degrees. So list those out. It says find the measure of each angle. So if you want, you can put it on the drawing that this is 140. So is this one. And then this one is 40. And so is this one. You can do it like that, or you could just list them. You can say, I know my angles are going to be 140 degrees, 140 degrees, 40, and 40. And you're done. Okay, you're also going to have a section, a true-false section, over postulates and theorems from section 2.7. And what they're going to be about, it's just going to be a statement about each of these theorems or postulates, and you're going to have to tell me whether you can determine if it's true or false. So know that the right angle congruence theorem states all right angles are congruent. So, for example, you may have a statement on the test that says all right angles are supplementary. Well, that's not true. We can determine that all right angles are congruent to each other because all right angles, their measurements are 90 degrees. So 90 degrees is equal to 90 degrees, meaning they're all congruent. They're definitely not supplementary. So watch out for things like that on the true-false section. Congruent supplements theorem, take a look over it, read it carefully, and know what it states. Same goes with the congruent complements theorem. The linear pair postulate, know that it's referring to a linear pair, and that linear pairs are always supplementary. So, meaning they add up to 180. And then vertical angle congruence theorem. Know that it states something about vertical angles are congruent. So again, just like the right angle congruence theorem, you may have a statement, something like vertical angles, or all vertical angles are complementary, or something like that. Just know that that's not true, they're congruent. Okay, so that's all I have for you for your review. If you have any more questions, please feel free to email me anytime today, and I will try to get back to you as soon as possible. But try not to email me past 5 o'clock. I usually don't answer any emails after that point. So everyone have a good rest of the day and study hard, and I'll pray for you that you do well on your test and you'll do the same. Have a good day.